Okay, and with that, I think we'll get started. Thank you all for attending. We'll get into it. My name's Matt. Um, what we're going to talk about today is the Polyfill.io supply chain attack that we've seen unfold over the last, let's say, week or so, as of today, July 1st, 2024. Very quickly, so you know who we are and who's speaking to you. I am Matt McGurk. I'm here from Source Defense. Source Defense is a industry leader in client-side security, web application client-side security. So basically the space in which this attack occurred. We have protected over our tenure about $20 billion in online commerce and thwarted about $8 billion in different types of behavior that one would want to prevent on their websites. So that's who we are. Once again, my name is Matt McGurk. I'm a solution architect here. I work out of the office of our Chief Technology Officer. My responsibilities include things like this, talking about the technology and evangelizing the topic, as well as working directly with our customers. I am a subject matter expert in this specific subset of cybersecurity. I've been here with Source Defense since we went to market about 5, nearly 6 years ago now. And I have about 15 years of web application development experience and security experience as well. So I should be able to address this topic pretty well and answer any questions you have, or it's going to be really embarrassing for me, personally and professionally. If you do have any questions as we go, feel free to throw them in the chat. I'm keeping an eye on that as well. I'm happy to answer those as we go, and we'll hop into the material here. So the thing we're talking about is an attack that occurred in the client side of a web application or web applications, like 100,000 at this point, I should say. The root cause there is the JavaScript programming language, as we're probably all familiar on this call. JavaScript is what makes everything in a web page interactive. It has no native security model in the browser, or a very lightweight one at the very best, and therefore is ripe for this type of exploitation. You may have heard the terms mage cart, e-skimming, form jacking, so on and so forth, all more specific or more well-branded terms for client-side attack, of which Polyfill I would call one. Polyfill exploits the common practice of using lots and lots and lots of client-side JavaScript, meaning code inside of a web page, to make a modern web application interactive and useful and user-friendly and such. You have roughly what I would call 2 different types of client-side JavaScript. You have what I would call first-party JavaScript, things like React and jQuery and other tools and libraries that an organization would build into the app themselves, like developers would directly integrate that stuff somewhere further left, so to speak, in their development pipeline. You also have what I would call third-party JavaScript, Facebook, Twitter, etc., where those files that make up those services are literally hosted on different domains, different hosts on the internet that are referenced by a web page, and therefore the code is loaded from those foreign places on the fly. Now, Polyfill is actually an interesting example where I would call Polyfill, this particular instance of this kind of attack, I would call Polyfill a third party in this case, because it's hosted on a CDN that doesn't belong to any one of these particular victims. I'll go into that a little bit more, but it's an interesting, not quite edge case, but a place where the 2 terms kind of bleed over into each other. A supply chain attack occurs because of the nature of JavaScript, again, in the browser. A little bit different effect, but JavaScript has a supply chain in the front end. You have things that are integrated directly into a web page, perhaps New Relic, like app telemetry tool, it doesn't matter what it is, but things that an organization directly works with. They have a vendor with a contract that supplies code, and that vendor chooses to host the code on their own servers, and the company's, the customer's web page integrates those by reference. You also have cases where those third parties, as I would call them, would integrate on the fly their own dependencies, their own, and this is a little bit different because we're speaking in a technical context this morning. I'll go a little more into the details. When I say includes or adds as a dependency, this is a little bit different than like a library file, which gets baked in further, like I said, on the left-hand side of this equation. These are more like full-blown applications that are called in by reference at the time the web page is executing. So in this example we're showing on the screen, Taboola might reference something called Solvi, which might reference its own instance of Google Analytics. So you do have that supply chain effect where these are all 3, 4, 5 different hosts on the internet serving different JavaScript files, all of which are loaded into a web browser and can then use any of the capabilities that the browser exposes to JavaScript, accessing visitor data, interacting with what the page looks like and feels like and how it works. All these different parties are now involved. So just to reiterate, I would call this a third party in this context because it's hosted on a different server. And then these third, fourth, and fifth parties based on their degrees of removal from the web page itself. So that's the idea behind a supply chain attack in the generic. Let's talk specifically about Polyfill. Polyfill is really like a picture perfect, to use the word I'm using here, a straight out of the textbook definition of what could happen and has happened to the JavaScript supply chain. Polyfill, the term, has a few different meanings that I wanted to unpack here just so we have the appropriate context. Polyfill is a generic programming term. It's a technique that's used. I'll describe in a little further detail. There's our specific polyfill files that you may have used, that one may have used to do the technique, to implement that technique of polyfilling. And then last and most specific to what we're talking about here, polyfill.io, which is a specific website and what I'm calling code as a service service that was originally created by Financial Times Labs a long time ago. So these three things if you're looking very specifically at this issue, you might hear used in an overlapping sense. I have seen a couple cases where folks are doing research and they find a comment in code, like they're looking at their own landscape, they find a comment in code and they see something like, this is a polyfill for IE 11. And just as an example, that would be referring to the first use of this term here in the generic. So I think it's important as folks are trying to look at their own environments and find their own vulnerabilities, you can see the word and the term used in other cases that does not directly indicate that you have a problem, really. So let's talk about each of those uses. Polyfilling, just in brief, browsers change all the time. There's new features implemented. And by features, I mean under the hood, in the guts of it, things like making animations a little better or making it a little easier to send messages back and forth between different parts of the browser. So real nitty-gritty technical stuff. As a web developer, it's always been kind of a nightmare to figure out what you're able to do when you're building a web app. Like if I'm targeting certain browsers, can I use this particular feature? Is this one browser manufacturer has gotten way ahead of everybody else, implemented cool new stuff, but everybody else. So you can see it's kind of a nightmare if you're trying to write code. I have little excerpts from a website I use to figure out what's available if you're writing a particular kind of app. Anyway, a polyfill then is a way of like kind of upgrading the browser on the fly. Basically, a independent developer will write all the guts that are needed to update the browser environment at the time of execution. Like, here's the tool that was added to Chrome, the latest version of Chrome. I'm going to write it in its own independent file so everybody can use it. So that's what a polyfill is. It's generically filling in a lot of different capabilities to make sure that what my code runs, no matter what visitor's web browser is hitting the web page, that is going to run successfully and how I want it to. A polyfill file then, or project, could be, it's any number of different files. If I was writing a web app, I might download one or more of these libraries, really. So I just have a handful I found on Wikipedia here. There are dozens, if not more. I mean, there's a lot of them. And so what I'm trying to say here is you might go, one way to do this would be to go find the features you need, grab all the files, integrate them into your web app, and then in the future, you know that your thing supports browser ID or some kind of feature of, or JSON 2 or whatever. So that's one way to do it. This obviously has its challenges and limitations. And also something worth using is, or thinking about is, this is all like 2014. We're talking about the beginning of time as far as web application, modern web app development is concerned. So this sounds like a big pain. How are you going to do this? How are you going to manage versions and dependencies? So along comes Financial Times Labs. And this is from a time when organizations were doing a lot of work, pouring a lot of dev and effort back into the web ecosystem independently, as you like open source and et cetera. So they decided this is kind of a nightmare. We're going to try to modernize this. We'll create a service called Polyfill.io. And Polyfill.io becomes its own independent community thing, not directly related to the Financial Times. So as we talk about this attack, and I don't want anyone to have the impression that the Financial Times is in trouble or did something they shouldn't. This isn't their problem, but this is where it came from. So Polyfill.io becomes this website where, as you can see on my screen here, you can check boxes saying, hey, I need this feature, and this feature. And then at the top of the screen, in that bundle URL, the website will spit out a URL that the web developer can add to their front end, to their client-side code. And then at the time the web page is executing the browser, it'll grab that code that's built on the fly to include the different features that you need, and thus modernize the browser on the fly. There's a lot of reasons to do this. It was very common back in the day to host JavaScript files and still today, as we can see, it was very common to host JavaScript files on a CDN, a content delivery network. So there's one common place on the internet to grab it from. There's a lot of reasons to do that. One of the first reasons was that the idea is kind of silly, in my opinion, but it made sense at the time. Was that if everybody had a common URL for a file, then browsers wouldn't have to download it more than once. Like it would be cached no matter where they went on the internet. It was back when bandwidth and everything was more precious. But you end up in this spot where, if you think about that first slide I showed, or rather not the first, but the supply chain slide I showed, where this is exactly that supply chain weakness. We have one common place on the internet where a lot of code is being served from, is integrated into, as we've seen over the past week, hundreds of thousands of websites. It provides a very core functionality, the actual library itself. It's like, if you think about modernizing the browser on the fly, that's a very invasive surgical thing that you're doing. It's not like it adds a pretty animation. It's a very core part of the web app, and it's an external dependency that can change at any time. All these organizations don't control Polyfill.io, which is how we saw the actual attack. So the question becomes, what happened to the Polyfill.io service to make it, for years, it was working just fine and doing its thing. What changed? Well, what changed was that, as I mentioned, over the years, this started in 2014, this thing became more and more enmeshed into the overall web. And again, I've said that number 100,000 over and over again. I would suspect there's quite a bit more than that. We're going to see over the next weeks. But in March of 2024, that domain name, polyfill.io, was purchased by a Chinese CDN firm called FunNull. And FunNull provides CDN hosting, as far as I can tell, for adult sites, gaming sites, that other kind of stuff. And they used a technique, and this isn't malicious, they just bought the domain and then they pointed the canonical name, meaning like, where should the browser go when someone types in or code references polyfill.io, where should the browser go? It should go to polyfill.io.bsc link.cn. So that's what happened. It moved from, it moved from a legitimate server, so to speak, to an identical copy of it, hosted at polyfill.io, etc., which contained malicious code itself, as we saw last week. I believe the specifics of the Polyfill package, the malicious code, were in the form of a redirect to another site. Totally makes sense given the nature of the FunNull business, that they would maybe redirect to one of their own properties, or instead of drive traffic somewhere else, right? So the illustration we're making here is some combination of maybe like domain squatting, a little bit domain takeover, basically poisoning on this particular domain. All FunNull did was purchase the domain on the open market and then configure it in a technically legitimate way. There was no exploit here. There was no vulnerability that was taken advantage of. They simply changed the setting. And then the code was loaded from a different server, and the code was different, and the code was malicious. You have two different scenarios where this affects a given website. Like, so for folks who were using CDN websites that were using cdn.polyfill.io as the place where their code got the polyfill files, basically. You have two different scenarios. One would be where the Polyfill IO code is referenced in a company's own web pages themselves. So if I was a developer at Source Defense, let me use at company.com, and I needed polyfill, maybe I stuck polyfill.io in my own code. I'm not literally downloading the file and integrating it. I'm just using that reference that you saw before to that URL. So maybe I did that, and because of the way the CNAME works, this canonical name, that polyfill.io part still works across the entire internet. Every single web app still hits that same domain, but because it's been pointed back at that new .cn address, it's going to load the different code. So we've got the first case where somebody directly integrates it into their web app and does it that way. You've got the second case where it's a more true supply chain attack, where one of the website's third or fourth or fifth parties, company.com, is legitimately integrating Google Tag Manager and Taboola, but Taboola, or etc., is adding some other service on the fly, which itself depends on the cdn.polyfill.io code. So that would be the second scenario. That would be a supply chain effect. They both have, the term supply chain can be used in both cases here, in slightly different senses. So they both rely on a poisoning of a part of the supply chain outside of the control of a particular company, of company.com. But one is because company.com has directly added that reference to their code, and one is because company.com has added a third or fourth or fifth party, which has in turn added that reference to their code. So the root cause is the same, that server basically changed out from under everybody. And then the code ended up in tens of thousands of web browsers, hundreds of thousands of sites, so millions of web browsers, one would assume. The code itself, I guess, just a quick tangent, there's not too very much in-depth analysis of it, because from the client-side security standpoint, once all this stuff happens, the sky's the limit, so to speak, for an attacker. They can tell the browser to do whatever they want. The attacker could simply skim credit card numbers, silently collect keylog data and send it to another server. They could redirect the visitor to another part of the internet. Whatever a browser and a web application can do normally, the malicious code can do at this point. So the root of the cause here was this, and then usually the discussion in these cases is about how did it get in? How can it be stopped? Rather than every single little iteration of the malicious JavaScript itself, because the capabilities are so broad, and the solution is also the same, is don't trust this supply chain so implicitly. So that's the idea behind how it occurred. What we saw, we did a little bit of our own research. Source Defense is protecting thousands of sites across the net. We see this kind of general unsafe coding practice of including a key component by reference from a CDN on the fly a lot. As I mentioned a little while ago in this presentation, this was and continues to be a very common coding practice, not just to integrate an open source library, but to do it at runtime by reference to another host on the internet. Obviously, we see here it's not a good thing. So we've seen quite a bit of this over the years. This is just the most splashy version of it. So how we counteract this kind of attack, how we work with it, we saw this back in February of last year. Of this year. We have been, for our customers, proactively managing what these scripts, both polyfill.io, its scripts, as well as similar ones, what it is and is not able to do. So our security model with our products is we're integrated into web pages, and we provide the least necessary set of permissions, like the lowest level of access, the narrowest level of access that a script needs to do its job, and nothing in excess of that. So for a long time, we've been redacting the information available to polyfill.io and preventing it from grabbing any malicious information. And we did see that, by the way. As of February 2024, we saw this particular script involved in this particular attack doing the behaviors that you saw on the left-hand side of my screen. Connecting to a blacklisted domain, accessing PII, personally identifiable information, credential data, and transferring data out of the browser. So all those behaviors were observed by source defense and blocked proactively. And then secondly, when the news broke here and when we saw other signals and et cetera, we have what we call policy recommendations. Effectively, our customers who were configured to have us automatically manage the security of their sites had this script blocked automatically. So this is the kind of thing that a security program, an organization, in my opinion, should have in place. I would urge folks who are looking at this to think of it in contrast to content security policy or sub-resource integrity. This attack was hosted on a known, trusted, acceptable domain, or a trusted vendor, their domain. And so content security policy would not have, would have permitted this code to load. If you wanted the website to work, if you wanted this super duper invasive key aspect, technical aspect of the site to work, this polyfill, then you would need to whitelist it in your CSP. The other thing is that sub-resource integrity. The most likely case would be that if someone were writing a web application and using this technique of including polyfill via reference, you would not be able to use sub-resource integrity. Because the library changes dynamically at the time of request, like the file changes. So a common criticism of sub-resource integrity is that you cannot, it's a fingerprinting technique, you use a hash to verify the integrity of the file. You can't have a hash that is successfully compared to something that changes all the time. You can't fingerprint something if the fingerprint changes at the time you take the fingerprint. So CSP and SRI wouldn't really have helped anybody here. And so as a result, a more active script management system, like what source defense provides, or some other technique, if that's possible, would thwart this in a successful way, whereas other techniques, in my opinion, would be much less successful doing that. The other thing that I would point out here is that we did notice this. If there was a little bit of Twitter discussion of, as there is, I guess X now. Sorry, I should get better at that. But one of the project owners of Polyfill.io, I believe this person was related to the Financial Times team and et cetera. But to their point here, they all created this project, but he never owned the domain name itself, which is like the key component of how this happened. The domain was sold and then the malicious stuff happened. That he made this announcement, hey, this is super scary, don't rely on this, don't trust it, on the 25th of 2024. And just a little note, we saw the first behaviors on the 24th. And actually, if you see that accessing data note there before some stuff that should be at least considered in 2023. So just an interesting timing there where, yeah, our system saw this before or as it started and was in place to make sure it works. The hallmarks of that, the mechanism that made us successful in this case was Source Defense Protect. It uses a variety of techniques to make runtime code, client-side code more secure, from isolating scripts from the page, changing what scripts can do, how they can access data, redacting certain kinds of data, making sure that rules are in place all the time and security mechanisms are in place all the time, not just in reaction to something, and without the kind of frankly nightmare of trying to get CSP and SRI to work in this scenario, which I think is pretty clear. It just wouldn't help with this one. So techniques, it's like actual proactive security tools in the front end of the web browser, rather than, unfortunately, playing whack-a-mole or having to extend. The thing about CSP and SRI, if I may have a brief tangent, is a lot of the time what ends up happening is it gets set, the actual security configuration is so broad, so permissive, that it doesn't do anything. So it's kind of like if you were installing a padlock on your valuables, and it's there, but you never locked it, is kind of the equation. Or you gave a key to everybody you ever met. That's kind of how most CSP implementations go, and something you might have to do. You might have to make it that permissive to work with this polyfill or similar example. Whereas we take a different approach of blocking down all the code proactively and enforcing rules whenever code is present and is running in the browser. What should you do now if you are an organization basically with a website? You're going to want to replace any references in your code to polyfill.io. As I mentioned at the top, polyfilling and polyfill files and the polyfill project, to give appropriate credit to the FT Labs folks and stuff, is a legitimate thing that you can use and you should use. The problem is, or if you need it, you should use it. But the problem is when you get it from a commonly hosted CDN, when you're relying on an outside computer to provide stuff to your visitors, it's a huge vulnerability and weakness. So make sure you're not using it. There are known good, clean versions of Polyfill on other hosts. I would recommend not doing that at all, and basically including it as far left as you can. You're going to have vendors who are going to use it. There's nothing you can do about that. But if you're using CSP, like I mentioned a moment ago, make sure it's actually doing something, and probably replace it for the reasons I mentioned, because it really wouldn't do too very much in this form of attack. And then, use a more sophisticated technique to do, because this is going to happen again. I've been doing this for 6 years now, and it is it happens over and over again. It's only going to get more prominent, and unfortunately easier to do. I think over the last 3 months, if you've been paying attention to the security news, we've seen more and more of these kind of like over time earned trust sort of attacks, where they seem to be Chinese nationals, at least the last couple, where they are infiltrating a open source project or otherwise gaining some kind of legitimate control through the commercial sale in this case. And so this is only going to happen more. The trend line keeps going up, as I've seen in my professional life. So if you do want to find out what's going on your own website, we offer free dashboards, free versions of our software. We can externally scan and derive quite a bit of data and analysis, including whether or not we see a copy of polyfill.io running on your own domain. So feel free to go to sourcedefense.com/freepci and sign up there. You can get that very, very quickly and understand your own problem, and if you have one, and what we could potentially do for you. So thank you, everybody. If you're in Europe, I hope you have a great afternoon. If you're in the US, I hope you have a great morning. If you have any questions, I am Matthew at sourcedefense.com. I'm happy to talk further. Thanks very much. Have a great day.